Okay, here we go. Hey guys, good to see all y'all, some of y'all, most of y'all. Hey, welcome back. Sorry for the short notice of moving us all online. We went over to Yaki this morning to do my CS411 lecture, and no networks anywhere. And one of the maintenance guys says, "Yeah, it seems to be pretty bad." So I was like, "All right, we'll move 411 online." I walked back to my office, no networks here either. It's like, and I figured there wouldn't be any networks anywhere else on campus. Looks like it's the wireless network that was having issues. They may have fixed it by now, but I have a wired network in my office, so there you go. Much easier to do it from here. Oh, hey, you get to see the office. Here's the office for all y'all to see. That's the office. Oh, it's all crooked. There we go. There we go. There's the nice desktop all the way around. It's a rocking office. It's my little bunny. Love my bunny. Here's Jimmy. It's my little Jimmy. All right. Yeah, 3 screens because those Java class names, man. All right. Hey, so. Yeah, you know, the sad thing is, like, we had a meeting the other day about the new CS building going up across the street, and they were talking about offices and furniture and so on. It's going to look like a damn dentist office. Like, every single office is exactly the same, all the same furniture, like glass everywhere. It's like, really, come on, this is college, man. Like, we need funky, I should be in an old converted cathedral or something, right? Yeah, it's just really sad. Like, all that money, you can't open the windows. And I complained about that. It's like, why can't we open the windows? Oh, because it's a LEED building, it's energy efficient. It's like, well, shit, like, I'd much rather just open the window and get some cool breeze through. Oh, and they also told us we can't have any trash. It is a zero trash building. They don't pick up trash. You got to bring it in, bring it out. It's like, oh boy. Fortunately, we got a couple years before we're going to move in there. Maybe I'll retire before then, or get retired if I keep complaining, right? All right, so here we go. Blip, 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 blip. My last lecture of the week, too. Oh, and don't forget, next week we're on a Monday schedule on Tuesday, so I won't see you until Thursday. I mean, I'll be around. I just won't have a lecture on Monday or Tuesday. The views, yeah, we're up on the 7th. I'll probably be on the 7th. We're on 7th, 8th, and 9th. Well, I mean, even the 7th will be nice, right? And all the offices have window views, which is kind of cool. I have a window view too. It's actually really pretty. Like, check this out. That's my view outside the office. Like, it's nice. There we go. In the spring, the trees sort of flower out, and it's just beautiful out there. Although, so watch this. This is my window. Ah, you might notice it's hard to see. They put a wall in the middle of the windows, both sides, so the windows don't open. There's windows, they have handles, but they put a wall against them, so you can't open them. I complained about that too. All right, here we go. We are discussing, yeah, Bernard, I saw that on the schedule too, a midterm in a couple of weeks. I'll have to take a look at that. It might end up being like a large quiz of some sort. I'll be honest, I've not looked at the exam, so I don't know what's on it. And it's probably on stuff we haven't quite covered or covered differently. So I'll have to modify that exam. But yeah, definitely expect an exam in a couple of weeks. It's going to be offline, so it'll be, put up on Gradescope. You'll have some time to do it. Like, you'll have 3 days to take that exam. I'm not going to do it during lecture time for sure. So we have way too much to talk about. I'll talk about that next week, I guess. Leanna says, why am I the only one teaching 210 this semester? I don't know. They actually canceled 2 of my other courses that were fully, like, I had 300 students in 2 courses. Both were canceled so that I could teach 210. I don't know why. Like, I don't even ask anymore. It's like, yeah, fine, I'll teach whatever you want to teach. Okay. It's weird. Academia is so weird. You know, it's funny. I got a minute. I sort of was thinking back over my life. It's like, should I have gone into academia like right away? Because I love teaching, and I love the teaching part, but the academia part is a little brutal. It's very political, and I don't like to play that game. So I'm kind of glad I stayed in industry and then came to academia later on. All right, let's talk. We're going to talk pointers today. It is Bernard is very cutthroat, and there's no jobs right now. I'm thrilled to have this job, which is why I'm not complaining much anymore, as I want to keep my job. All right, let's talk pointers. Pointers and references. So I don't know why, everyone makes a big deal out of pointers, the mysterious pointer. It's like the mysterious Isles of Langerhans. No, a pointer is just a variable. Like an integer is a variable that holds an int, or rather an int is a variable that holds an integer. A pointer just holds some value. The value that it holds happens to be an address, a memory address. That's all. It's just, pointer's a type that holds a memory address. End of the story. It also knows what thing is in that memory address. And a lot of this might not be clear. It'll be clear in about 5 minutes as you see how they actually work. It's so much easier to show you than to talk about them, I think. Bernard. So I'm talking about pointer, the mysterious pointer. So I glance over at the chat to see if anyone has a question. What I see is it's cutthroat. It's like, pointers are cutthroat? I don't think so. So again, it's just a variable. A pointer is a variable. The Java dev folks, when they designed Java, they thought pointers were so scary, they took them out of the language. I mean, they're still there. They still use pointers under the hood, but they don't really give you access to it really the way we have access to it in C. So a pointer is just a variable, right? So let's look at it. So you've already seen one operator of the two we're going to use. Like this, we've got this int age. Remember the scanf that we did? Scanf reads things in from the console, right? Or from some stream, happens to be the console in that case. Well, if I have a variable called age, scanf wants to store whatever you type in at the address of age. And so we use that address of operator. It's the ampersand, the address of operator. So if that's age, that's the address of age. There's not too much more fancy than that. Let us go and look at some code. Excuse me. Let's do a new project. File, new project. C executable, put it in pointers 2 so we can write some stuff. Great. This window's fine. Fine all the time. And looks like we're all synced up. Sweet. Sweet, sweet. Let's see if she runs. Get rid of that. You gonna run? Hello world. Sweet. It does run. Let's make a couple of int age equals 40. Float foo equals 123.45. So there's a couple of variables, right? I'll put another int in there. Int baz. Let's put a breakpoint here. We're going to go look at those in memory. Get the little bug up there to run the debugger. That's upper right. That little bug runs the debugger. And we have a breakpoint right here in line 6. So we stop the program there. Let's go take a look at the variables. Rerun that. Yeah, it's weird. Every once in a while, CLion, when I do a debug like that, it's like it hasn't quite synced up with the container yet. And so I get this blank variable screen. If you just rerun the debug session, this little guy over here, rerun it. If you rerun it, it picks it up, usually the second time. All right, here is age. Well, let's take a look at it in memory. I right-clicked on this. I'm going to select Show in Memory View. Looks pretty good on that screen. So there it is, right? What we have in age is 40. So this is in hexadecimal. Anytime we're working in memory, if we're not in binary, we're probably looking at it in hexadecimal notation. So we've got a 28 in that location. So in hex, it's powers of 16, right? So 16 to the 0, 16 to the first, 16 to the second. I've got 2 16s, which is 32, and I've got 1 8. So 32 plus 8 is 40. So age lives right there. And notice it's backwards. It's really 0, 0, 0, 0, 0, 0, 2, 8. This is must be a little endian system. We'll talk about endianness, like which direction things are stored in memory. That'll come up in a future lecture. But that's our 40 sitting in memory. And if we want to go and look at foo, let's go and look at foo. So foo is right next to it. It's a little tougher to see it because that's a float value, and it's got an interesting format in memory. I've got to take care of that decimal place, right? So I can't just write, 123, 123. Like, where's the decimal go? It has a special format in memory, which is why we can't just read it directly. If we knew the format, we could read it, I guess. I don't know what the format is yet. But those are those two variables sitting in memory, right? But let's look at, let's go back to age. I wish it would clear that. I don't know why it doesn't clear that. Here's age over here, that 28. Where does that live in memory? Well, the memory address is over on the left here. So here's the memory address right here. That's the actual memory address of this location. So the way you read these tables is it shows you memory. So it shows me 4 bytes at a time, right? So it's 32 bytes going across the screen. And the memory address we see here is the address of the first byte. So this guy lives at C0, that's C1, and I'm just reading the last couple of digits here because all the remainder are the same. So 57C0 is there, C1, C2, C3, C4, C5, C6, C7, C8, C9, CA, CB, CC. So age lives at blah, 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 357CC is the address of that byte. It's an int, so it's 4 bytes long. We're going to be working with these things over here. Like, we're really interested in the addresses of these things. That's what pointers are all about. They work with the address of something. Let me stop that. Pop back here. So it's just the same way scanf worked, right? When we said, actually, let's do it. Do it now. Let's pull that out. And we'll just stick that over here. That's going to replace these. At some point, we'll stop replacing and fold some stuff up. Rishabh says, what would be the location in memory of 123.45? Well, we've lost. Oh, no, here it is. Let's find out. So it starts there, right? So that would be C0, 1, 2, 3, 4, 5, 6, 7. It starts at C8. So all of that 357C8 is the first byte of that what the book that was, a float. Yeah, because it's 4 bytes wide. Rishabh says, what did I say, C8 through CB? I probably wouldn't. I would just say, hey, it's a float at C8. And we know they're 4 bytes, so you can add a 4 to it if you want to. Oh, yeah, so here's that scanf thing, right? Let's stop it right here. Rebuild this. And let's debug it. All right, so here's age. Let's look at age in memory, show in memory view. So there's that 40, hex 28 is 40 in decimal. So there's that value there. And now I'm going to read something in on the console, and I'm going to place whatever's read in on the console at the address of age, the address of age. And so we should see that value change if I can manage to make this happen. Let me just stick a breakpoint there, and we'll run to the next breakpoint. So I need to go to the console and type like a, I don't know, let's type 21 or something. Yeah, I wish. Turn, and now we're back here. And you can see that's the memory location, right? and it changed from whatever it was, a 40, and now it's a 15. So 15, hex 15, there's 116, there's a 5, 16 plus 5 is 21. So that's the decimal value 21 sitting in that memory address. And you can see that when we read the 21 in, it just put that 21 at the address of age. So that's the address of operator. You've already used it. That's what it's actually doing. It's going to that address and dropping a value in that memory location. That's not so bad, right? How about the other way? Going the other way, so to speak. So, like, we can get this stuff in memory. It'd be really useful to use whatever's there in memory, right? Like to manipulate that value in some way. So we're going to use a different operator for that. Hexadecimal, hexadecimal. 15 hex is 21 in decimal. You guys should know hex back of your hand. Hex and octal. If you don't know hex and octal, you need hex and octal. I don't teach it in here because you should have gotten it in some of your other courses. 111 should have taught you hex. Taught you? Holy shit. 111 should have taught you hex. Or if you took 101 with me, I teach hex in 101, hex and octal. All right. We're going to use this operator, the star. Now, unfortunately, star has overloaded meanings depending on where it is. But you'll see both in the next few minutes. And I think it'll make sense. Like, there won't be any confusion about what it means. All right. So the star operator. The star operator, technically it's called the dereference operator. Excuse me. I call it the value at operator. So the value at, like this. Let's just pop this over there. Copy. And this is in the slides, so I'm just going to replace that. Let's talk about what's happening here. Stop. And get rid of those. Let's talk about what's happening in this code. Here's age. I'm setting it to the value 11. Now, the next thing I wanted to do is create a variable called age p. Age p is going to hold the address of age. That's how you read that. Age p is assigned the address of age. That address of operator we've already used in scanf, so it's like we know how that works, right? Well, I need to know what type of thing is at that address. You'll find out why in a few minutes, but I need to know the type. So pointers have a type. Here's the type of the pointer. It's an int pointer. So in this location, that star, when I combine it with a type like this, that gives me the type of the pointer. This is an int pointer. What's it pointing to? What is at the address that it's storing? It's storing that address at age. The address of age has an int in it. In this case, it's got an 11 in it. So that's the notation to create the pointer. It's the type star. If it was a float pointer, it'd be float star. If it was a double pointer, it'd be double star. Long int pointer, long int star. That just creates the pointer. That's the name of the variable, just like before, just like age. That's its name. What's in it? Address of age. Now, watch this. What's your age so far? Let's see, I'm using this. Hang on. Let's debug it and see what it looks like, and then I'll talk about what that is. Build it. Debug. Oh, it's waiting. It's on the scanf already. Let me stop it earlier. I'll stop it there. And I'm just going to rerun the debug over here. Rerun it. All right, so now we've got an 11, right? Let's go and look at that age value in memory. So here is age, show in memory view. There's age. It's got 0B in it. 0B is 11 in hex. I've also got this guy, and look what's in there. So here's what's in age P. So here's age, right? Age has an 11 in it. And then age P has the values, this thing. It ends in 56A4, 56A4. Let's go down and look at the memory view. So blah, 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 7FF, et cetera, et cetera. 56A0, that's the address of this byte, that 90. So this is the address of the first byte. That's A1, that's A2, that's A3, that's A4. So at A4, which is what this guy is holding, there's A4, see, in HP, it's got an 11 in it. Make sense? I'm going to pause and let you guys think about that. Just make sure everyone's cool with that.
This means though, however, that like there is some point in memory in which HP, in which that address is stored, right? In which kind of this hexadecimal number is
Yeah,
stored
actually,
in
so
memory.
we can look at it. Hang on, let's find it. Let's go and look at the address of HP. Happens to be right next to it. So here's what's at the address of HP. Remember, it's just a variable, right? So it's got some value in it. The value is blah 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 7F FE B7 A7 56 A4. Blah 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 FE B7 A7 56 A4. So what's in that memory location? That's the address of HP. That's the address right there. That's what's in it. And what's in it is the address of age. That help? Oh, let's keep going.
Well, I'm sorry, one more question.
Why is
that reverse? Why is that in like reverse order? Like, so the address is OX, right? And then 7F, and then that's the last byte, and then it's FE, and then B7, A7, 56, A4. Why is that
and
kind
the
of
same
in
thing
like
down
reverse
here,
order?
right? So when we stored the 11, we stored it as, that's the 11 right there, but it's really 00000011.
Oh.
Yeah, so on this machine, values are stored in memory from basically left to right. The left side is the least significant byte. It's called the little endian. I'll type it on chat. Yeah, you got it. Gabriel's got it. It just means that we're storing the little end, the smallest end of that value on the left. If it was a big endian machine, it would be opposite of that. We go 0000000B. That's going to bite you, by the way, because when you start getting into some really serious C code, it makes a difference whether your target platform is little endian or big endian, because we're going to be working with individual bits in memory. You got to know which order they've been stored in. And like that's part of the build process. Like, what platform am I building on? I'm going to have to do things opposite one another depending on which platform I'm on. I know. Yeah, yay. Yeah, I'm not here. Yeah, you read it basically. I would read these right to left. So I would say 0000000B. That's the value 11 in that int. And same thing over here. So this is an address. It's going to be 32 bits. 00007F FE blah blah. This on this side, that's the real arrangement of it. Like, it starts big to small. This is written small to big. I know it's confusing. It's an historic, yeah, and I was going to say hysterical. It's an historical thing that some machines were just built differently. Like, the physical hardware was built differently than others, and both became popular around the same time. And so we needed to support both. And so now you got to know, which are you, little endian or big endian? And we'll have a whole lecture on this sort of stuff. So, like, for now, just realize that in this case, you read right to left. And we'll talk about why and how to manage that later on. Never use blank. Yeah. Aaron, what's scanf doing in the code? Same thing it did in your code that we, have played with for the past few lectures. It's just reading in a value. But Aaron, I bet you are wondering about this, aren't you? What's that? Actually, so let's change it. We're stopped here, right? Let's keep going. Yeah. So let's execute the scanf line. Here it is. Step over. So we're running the scanf piece now, and take a look down here. That's the 0B, right? And I'm going to type something else in. Unfortunately, I have to do it on the console. Let's do like a 55. And now we're at the next breakpoint, and you can see that it changed, right? Actually, that tells us that it changed. So now it's 37 hex, which is 3 times 16 is 48, plus 7 is 55. So that's the 55 that we just typed in. Scanf takes a value from the stream, sticks it at the address of some variable. We took a shortcut here, right? Normally we've been doing this. Let me just stop that. Before we were doing it this way. So just ampersand age, the address of age. Tell scanf to store that value at the address of age. Well, what variable do we have that has the address of age in it? Yes. So 3 things. You got it. We have a variable already called age p. And age p, what's age p hold? The address of age. So they're exactly the same value. We can just down here say age p. How about that? Good thing there's a weekend coming up. You can all rest from this lecture. Everyone clear on what's happening here? So all I did was say, hey, I'm creating a new variable. Its type is int star. It's an integer pointer. I'm calling it HP, and I'm setting it equal to the address of age. There's age right there. And here's age right down here. No questions. Sweet. You guys are handling this better than A1 did. I think you guys are more mature. You're like an hour older than them, so you've got that extra maturity going for you. Do we need a pointer if we just use ampersand age? Chris asked. No. So if you did it this way, whoops, just ampersand age, right? Oops, shit. If I do it this way, if I just do that, ampersand age, that's the old way we've been doing it. It's exactly the same thing. Store that value at the address of age. Well, I've got a variable here that has the address of age in it, and I'm just going to use that instead. So it's an either or. You wouldn't do both, I don't think. What are pointers useful for? Asks everybody. So I'll say this. From this point on in the course, the entire course, we're going to be dealing almost exclusively in pointers. It's just, that's what C is. C is pointers everywhere. And working directly with memory values and manipulating bits in memory, that's why we program in C. It gives us so much control over what's going on in the hardware. No other language, except maybe assembly language and maybe some specialized embedded languages, like no other like popular, high-level language really gives you this. Like most of them are really abstract. Like Java, you're not going to see anything written in Java that needs to run fast. Java just doesn't run fast. It's such a pig because there's so many levels of abstraction. When you're coding in Java, you're coding at a really high abstraction level. And by the time it gets down to the hardware, all those levels, like all those layers of abstraction, each one adds, performance hit. So like, of course it's going to be slow. It has to be slow. In C, there's nothing between us and the hardware. You're basically programming the hardware at this point. There's no abstraction. The advantage is, there are a bunch of advantages. One is that if I need something to run as fast as possible and I don't want to write it in assembly language, I'm going to write it in C. If I'm writing in Java or JavaScript or TypeScript, which I love these days, or Perl or Python or all those guys, even though at that point I'm writing at an abstract level, if I understand C, and like if you guys never write C again after this course, I hope you do. It's a fun language. But once you've been through this and written all this C code and manipulated all this stuff so directly, even when you're programming in Java, for example, like you understand, you get it. Like you get what's happening when your program's executing. You know what the machine is doing because you've done it in C. And all the other languages do exactly the same thing, except they abstract it all out. You've done it directly, and so you understand the fundamentals of what the computer is doing. And that's why 210 is so important. I mean, 111 and 112, of course, are important to get you like going. 210 is really the fundamental course for computer science, I think. At least in our curriculum, it is. I think it's everyone should be. I remember, I can't remember if I said this in here in A1. Like I remember when I came here years ago and looked at the curriculum, I said out loud in a meeting, why are we not teaching everything in C and assembler? And the looks I got, holy crow, I never said that again, but I believed it. Like we're computer scientists, like we should be doing this first. Like I would be teaching this in assembly language if I could. But C is sort of where we went to with 210 at least. It's a really fundamental view of what the computer is doing. That's why it's so important, I think. Somebody's asking an actually code question. Geez, OP. Nicholas, what? Why printf? Oh, yeah. So you guys, you're reading ahead. What the hell's that? What's star HP? Let's look at the slides. That we just talked about. Wait a minute. What's that? Star HP. This is the second meaning of asterisk, unfortunately. I just want to kick somebody. Like, why couldn't you just pick a different symbol here instead of using exactly the same symbol? I guess it's so as we know it's a pointer sort of thing. Technically, this is called the dereference operator. I call it the value at operator. So this tells me the value at age P. What is age P? What's in that variable? It's an address, right? And so what this is really saying is, what's the value at that address? The value at the address is, right now, it's the 37, it's 55, 37 hex. That's the value at that address, the value at HP. So if I have an address in a pointer somewhere, I can dereference the pointer with the star, the value at that pointer. And by the value at the pointer, it means the value at the address the pointer is holding, some address in memory. Yeah, so Sanjina and Rishab and you guys, let's try it. So the question is, actually, let me just run this. So let's rebuild just in case. We'll run it. So it wants some value like 44, right? So your age so far 44. The value at HP is the address of age. Age has a 44 in it, and so the value there is 44. The question was, what if we do this? Your age so far. I gotta rebuild. 44, and what I get is there's no dereference here. There's no value at, so it's probably going to print out the address, right? Blech. Let's change the format so it's at least a little cleaner. Let's put an X here, which is for hexadecimal display. And we should see something a little bit cleaner there. Here's my 44. That looks like a memory address, right? So as you guys pointed out, like if we leave the star off, we're just printing out the value of the variable itself. And what's in that variable? It's an address. It's the address of age. And that apparently is the address of age. Let's find out. Is it really? Debugger, whoops, console rather, 44. All right, so HP has 184 in it. So it's got blah, 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 F184, which is the address of age apparently. What's down here in HP? F184. And if we just let it run, We should get F184 is what it printed out. Aaron says, isn't HP the address of age? It is. Why are we not changing the location as the input? Because the pointer holds an address to an integer in memory. Jonas, yeah, you've got it, man. Yeah, I couldn't have said it better. Jonas has it. He says, we're saying, hey, please store this integer at the address I'm giving you. It's like, like you run into your friend on the street and it's like, you want you put your phone back in your room or something. You hand them your phone and say, hey, would you put this back in, Warren's 7th floor, room 20 or something? You're telling them the address you want them to put the phone in. Same thing here. We're telling it the address of age, in this case, that we want to store a variable in, store a value in. Is that because age p is an int pointer? Yeah, you got it. And if I try to put something else in there, let's see if it'll even let me compile it. So I've said this is an integer pointer. Well, let me put a double in there. So a double's bigger than an int, right? And instead of, let's make it a different one, like int pointer foo p equals address of foo, like that. Is that going to compile or not? Let's find out. Oh, it actually compiled. Oh, that's interesting. What's the problem here? Double's bigger than an int, right? I think they're double. I think it isn't a double 8. Right now we're talking about Warren. So I said, hey, stick the address of foo in here, but I tell it was an int instead of a double. What's going to happen is it's only going to use an int size. It's going to expect an int size value inside that memory address. Even though it's 8 bytes long, it's only going to look at 4 bytes of it because an int is 4 bytes. But notice that it did not crash. Like this compiled just fine, right? It probably generated a warning, which we don't have turned on right now. So it'd probably warn you about that mismatch in the types. But like, it was fine doing that. Yeah, it's only, well, it's store the first 4 bytes because an int's 4 bytes long.
Wait, I have a question. Like, isn't, so in the address we store, right? So int star, like int kind of the pointer, int pointer of foo p, then stores the address of foo, right? But it's not like, as we said before, it's not kind of C8 to CB, but instead it's just C8, right? So shouldn't it work regardless of what foo is, because it's always the address, and the address is always kind of the same size, right? It's always hexadecimal, so it's always kind of the same length. It's just kind of what comes when you actually put a value in there, and then it might overload until like not just the stored offset, so to say, kind of. So it's not just 4 bytes, but it kind of then goes over there, right?
Yes. That's exactly what happened. Well, what's happening is, so these things, right? Foo p, age p, these pointer variables, they're always exactly the same size, right? They're all 32 bits long. It's 4 bytes. So a pointer itself, when I say I'm creating a pointer variable, like here, foo p occupies 4 bytes. The thing it's pointing to has different sizes though. So if I say, let's say it's a long double, that's a really wicked long thing, right? Well, even though foo p will always occupy 4 bytes because it's just an address, and addresses are 4 bytes long all day long, no matter what's in them. When I go and actually use that, like here, we said the value at that thing. When I do value at like that, it says, oh, what's the type of the pointer? What is age p's type? Age p is an int pointer, and so it's only going to take the value of the first 4 bytes of that address. In a long double, that's a freaking long variable. I set up an int pointer though. If I then try to get to the value that is in that pointer, like the value that's pointing to, it thinks it's an int and it's only going to look at the first 4 bytes. Even though there's more data, it just looks at the first 4 bytes because I told it was an int pointer. And it knows that an int's 4 bytes long. It might make more sense as we come up, we're going to do some manipulation, and it might be obvious as you see things changing in memory. I think that'll help. I'm actually going to remove these because that'll cause you a world of hurt. What? Samantha says, can you use the value at star for only pointers? Or like value at? Oh, would value at age look like the value 11? Let's try it. You know me. So that's the value of age, right? It's like, oh, no, why not? It's not a pointer. So the answer is, it only works with pointers. I don't think it'll compile. Yeah, it craps out. All right, let's keep going. So I got stuff to talk about here. That's it. That's kind of pointers. Like the pointer, it's just a variable. What's in the variable? An address. What's at the address of? Something that we stuck in there, right? It's like a pointer is just a variable that holds an address, end of story. There's not much else behind that. What is the Morris? Do I want to know what the Morris form is? That sounds disgusting. Like you need to see somebody about that.
I think like it was like a bug that was abused by like a university student who kind of figured out kind of the offset. If there's like something stored in memory, it's kind of allocated, and if you then go over that, and then he kind of made a self-replicating piece of software that kind of crashed a bunch of computers in university. Yeah.
Oh, fun. Well, you guys will be able to do that too. Actually, we'll try that later on. We'll like go beyond the bounds of an array, and you can see it's like, C, you don't care. C is the honey badger of programming languages that don't care. You just don't care. And if you haven't seen the honey badger video, for God's sakes, go watch the honey badger video. Not right now. Do it after class. Funniest thing. Oh my God. I just laugh my ass off every time. All right. Here's the question. Why does a pointer need a type? We just saw a little bit of that, like I just talked about that a little bit, right? Like a long double is wicked long, is a big ass thing in memory. And then when I try to go and get the value of it, really when I dereference that pointer, it looks at the type of the pointer. It says, oh, it was an int pointer. I'm only going to look at 4 bytes of it. So we need to know what type is being pointed at so that we can do the proper thing when we dereference. When we use the value add operator, I need to know how big that value is. The definition of the pointer tells me what the value is, how big it is. It's an int pointer, it's a float pointer, it's a double pointer, and so on. Let's try this. This is fun code. I'm gonna just, let me just do that. Actually, this is all on the slides, right? I can just replace it. All right, here is there's a couple of tricks in here, by the way. We'll get to them. Here's an array. What's the array? It's an int array, and it's got 8 values in it. By the way, this is a really quick way to initialize an array. You just hand it a set of values, and it'll put these in the right spot. So 1 will be in the 0 spot, 2 is in the, let's make this, let's do it that way. So that's really obvious. So 0's in the 0 spot, 1's in the 1 spot, 2's in the 2 spot, 7's in the 7 spot, and so on. 8 values, right? Let's take a look at them in memory. Let's do a build. Let's debug. Here is that array in memory. I got to rerun it again. This is so weird. It's always something. What do you mean variables are not available? Why would variables not be available? Stop. Let's do a rebuild. Try it again. Memory view. Really? You're going to do this to me? Let's move the up pointer. Hang on. Let's try it here. Stop it. Oh, come on. Really going to do it? Memory view. Why is that? Huh, that's really weird. Hang on, let me just screw around with this for just a sec. I don't want the disassembly of it. Let me stop that. Let me just change something. Standard array. Oh, that's fine. That's fine. Good, good, good. And I'm just going to do a quick tools. Let me just rebuild the.
Professor?
Yeah, go ahead.
I think the mistake is in line 5. I think you're supposed to point it to the address of numbers and not numbers itself.
You would think. That's not the case. Here we go. All I did was reset the CMake. I did this. I did tools, CMake, reset the cache. I think it's because I was just copying and pasting so much code that it lost its mind there. All right, take a look at this one in memory. Right click, show in memory view, or command control return. You want to do it on the keyboard. Here's the array. Actually, you know what? I'm going to change those numbers back because there's too many zeros. Let me stop that. Let's go 1 and 8, just because they're easier to see that way. Save that. Build debug. All right, that's easier to see, I think. Here is the stuff in memory. So that's the array, right? 1, 2, 3, 4, 5, 6, 7, 8. Those are the values. 0, 0, 0, 0, 0, 0, 1, and so on. Now, what's interesting about this is see how big they are? So that is, the 1 is 4 bytes wide, right? The 2 is 4 bytes wide. The 3 is 4 bytes wide. It's because they're integers. Now let's set up a pointer to them. So I'm going to go down here, click my step over button, like that. And now I've got a pointer. Let's go look at the variables. Here's numbers P. What's it hold? It holds CA90. Well, is that where this was? That starts at, that first byte is this one, CA90, right there. So you can see that that's the first, that's the address of the first item in the array, right? Well, watch this. And I'll get back to your, I don't know who was asking the question. I'll get back to you about why is there an ampersand there. Let's run the print. But look what it's doing. What the heck is that doing? Anyone know what that's doing? What's it going to print out? +3. Well, you might think it's going to go to CA90 and go 1, 2, 3 and print out a 0, but that's not the case. When I use the dereference operator, the star, how do you make a star? The star, the value add operator, now I've got something called pointer math going on, pointer arithmetic. And when I say the value at numbers P +3, what that's really saying is go to numbers P, whatever address that is, and go up 3 integers, not 3 memory address locations, 3 integers. So if we look at the value numbers P, that's holding CA90. So here's CA90, it's this byte right here, those 4 bytes. If I go 3 up, there's 1 + 1, there's +2, +3. So it should print out a 4 on the console. Let's see if it does. 4. It printed out a 4. How are we with that? Yeah, so Rashab, it's not 3 to the address. I'm adding 3 ints. Why? Because that was an int pointer. That's why the type is really, really important. Because remember, in C, all of these things are stored in different size chunks in memory. An int is 4 bytes. A double is 8 bytes, right? They're different. And when I want to access those values doing things like this, I need to know what the type is. So I need to know how big a chunk I need to skip ahead. When I say 3 here, it's 3 chunks, 3 int size chunks, not 3, not +3 really. It's not, what was the address? It was not running. So it's null. Go forward one. So it's at FFD0 right now. So I'm not looking at FFD3. I'm looking at 3 ints from the start of that array. Now, back to somebody's question was, what if I had a +9? Something larger, Olivia. Now you're thinking. Now you're thinking. Let's go look at this pup. All right, that's there. Let me go up 5. No, I don't want to go that. Let's go like +3. That's 8 wide. Let's go 9, 10. Let's go 10 up. And I want to know what's in that location. It's going to print something out, right? So let's stop that. We run the debugger. And let's set up our pointer. All right, so now here's numbers. Sitting at, now we're at A3D0. It's different because it's a new run of the program. Just puts it in whatever memory is available. So that's sitting at A3D0. What's +10? Well, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. +10 is here. So let's see if it actually prints out +10. Console. You son of a bitch. It didn't see the change. Hang on. Yeah, let's debug again. Forward 1. And if we keep going, now we get on the console, we get 11. Is there an 11 there? I don't know. Let's try it again. We should be able to figure out what it's going to print out, right? So let's go up 1. Let's take a look at numbers in memory. And so that's 8, 9, 10, 11. That here somewhere, I think. I'm guessing it's going to print out. Wow, that's some weird value, though. I don't know what that's going to print out. 11 again. The point of this is that there's no bounds checking, 0 bounds checking. You can go, let's go -1, like minus -1, -1 inch, right? And we'll go up 1. Let's see what's here. So now we've got -1 would be these zeros up here. So it's probably going to print a 0 in this case, I think. Yeah, it's a 0 there. There's no bounds checking to answer those questions. You can go beyond the array backwards. You can go beyond the array forwards. You're accessing memory directly. And C assumes that if you're doing that, you know what the hell you're doing. And it doesn't check anything. It does not check anything. What does that mean for us as devs? We're going to have to spend a lot of time checking all that shit because nobody's checking it for us. And somebody pointed out in the Morris worm, like, you can go anywhere you want in memory, put whatever you want there. If you can execute the program and you have access to that memory allocation, it's yours. Like, do whatever you want with it. You know, C sees that and says, I don't care, like whatever you want. You -1, you're going back 1 before the array even starts. Like, I don't care, it's a memory address. And it just does it. Bold of C to assume I know what I'm doing. I know. I feel the same way, man. And I've been doing this a long time. I still like look at stuff and it's like, what? Like, why is that happening? Oh, sorry, back to the original question, which was this thing. Why is that not that? Anyone know why? Why can we do that? Nobody knows. Let me run this again. It's this. So in the special case of an array, In the special case of an array, the variable, numbers itself, the variable numbers, what's in that value is the address of the first item in the array. So if we could get to it, I'm not even sure I can get to it. Excuse me. But what's in, oh, can we do this? Address of numbers. Can I just look at numbers? It probably won't let me because it's not a pointer. Not a pointer. Yeah, I don't think I can get to it. But what it holds is the first item in the array, the address of it. If you think about it, it kind of makes sense because if I've got a bunch of stuff sort of organized sequentially in memory, there's no real clean way to like, I don't want a variable that has all those values in it because that would just be a big chunky variable. It's like, and how would I like even get to those things, right? And so instead in an array, and again, it's like, it's pretty special to arrays. In an array, what I really am interested in is what's the first one. I know what type is in there. I know they're ints because I said this is an int array, right? And so if I can find the first one, I know that the next one is 4 bytes away. The next one is 4 bytes from that, and so on. So I can do kind of internal math. C is doing internal math to figure out, like when I say number is 6, it's really just starting at the beginning and going up 6 ints to find what's in that memory location. So because of that, because arrays have this property of the variable, the defined variable is really holding an address, I can do that. So I have a pointer, it expects an address, numbers is actually an address. And so I can store it in that pointer variable. I'm not Aaron says, it reminds me of a linked list. It's exactly what it is, with the exception that in a linked list, like it's slightly sideways, right? In a linked list, each item in the list has a reference to the next thing in the list. Here, I'm actually doing math on it. So it's not that the 1 points to the 2, it's that the 1 is 4 bytes away from the 2. And C knows that because it's an int. So if I want to go there, it just starts here and goes up 1 int, 4 bytes. Yeah, if I don't put the ampersand there, or if I do put the ampersand there, I think that might be a compiler error. Let's find out. Let me try to build it. Yeah, it hates that. We could force it somehow. I'm sure there's a way to get the value out of numbers and force it and cast it into something. Why go through all that pain, right? This is how we're supposed to do it. And by the way, you'll be doing linked lists in here, and you'll see how we do it in here in C too. Isn't this fun? I love C. I'd forgotten how much I loved C. It's just really fun. All right, actually that's exactly what we were just talking about, right? All this stuff, we just did that. So I'm just gonna flip through these slides. That's the picture that we just saw. How about passing values? What have we got? 15 minutes, perfect. Let's pass some values. You might have heard the terms pass by value, pass by reference, and so on in different languages. Like, oh, Java always passes by reference and so on. What they mean is when I call a function like this, like these two guys down here, when I call that function add1, what exactly am I passing? Here it expects an integer. Well, watch what happens. In fact, let's just copy all this. Copy that over here. It's going to stick it here because this was all in the slide. And where's my function? Here's my function. Copy that. Stick that function down here. I need a prototype, right? Split it. Copy that. Stick it up here. All right, everyone should be happy now. Save that. Let's talk about this. Variable, it's got a value. I'm going to call add1, and I'm going to pass that value. I'm going to take that value and add 1 to it, and then return it, and then print it out. What do you think this prints? Is it print a 1 or a 2? One, two, one, one. Everyone else is asleep. A lot of ones. Shut that off. Let's build it. Run it. We get 1. Why? We passed by value. So passing by value, you'll actually hear people talk about C passing by reference. It actually doesn't. C always passes by value. There's a slide on this. It's a really like subtle view on that, and you're never going to be asked, to explain why C really passes by value than reference. Maybe if you want to bring it up in an interview or something to show them how smart you are, but it's not something we normally think about. We sort of abstract it. What we want to do is pass references to memory locations, pointers essentially. And so we say, oh, we're passing a reference. It's not passed by reference, we're passing a reference. That's really the difference. But what's happening here is I'm just passing a copy of 1. Pass by value means I'm going to take the value, make a copy of it, and hand it to the function that I'm calling. And so this one and that one are different ones. They're in 2 different scopes. So when I modify one down here and then return it, I'm not even capturing it up here, right? So it's not changed. This one up here is not changing because the one that's in scope here still has a 1 in it. This one that's in a different scope, I modified, did whatever, that's a different one. So it just prints 1. Passing by value just means, like, literally here, I passed the value 1. If this were a 2, I would pass the value 2. It's just taking the value that's in the variable and passing it down. In some languages, you always pass references. You're always passing an address. In this case, not. Yeah, and Edwin, it's because they're 2 different ones. They're 2 different values. You can make it really clear, different one. That's really what's happening, right? Like the thing coming into this, that 1 gets assigned to this variable. Now it's called different. So they really are different variables. How would we write this if we wanted to really manipulate that 1? Like, how would we do that? Yeah, Anderson's got it. You just give it the address. So it would look more like this. And I can put this down here because they're different, because they have different signatures. Let's call it 1P. And I'll get a little split it so I can get that. Stick my prototype up here so we can see it. And we're going to use it like this. Notice the difference. Now the function is assuming we're going to give it, let me just move it up so we can see it better. X, stick it there. Here we go. Now, what's the function? What value is it bringing into the function? It's not a value, and it's not that 1 anymore. I'm passing it the address of 1. Anderson has already typed that. I'm giving it the address. Once something has the address of something in memory, you can do whatever you want with that, because that's the actual address that variable lives at in memory. And so that's exactly what we do down here. So the value at that spot, we're going to set it to a 2. And notice that I return here, but I'm not returning anything. I said void as my return argument, my return type rather. I don't have to return anything because I have the address of that variable. I'm going to manipulate its value. There's nothing to return, really. It's like I just did the work. I'm not going to pass a value back. I don't have to. I just manipulated it directly. And let's call this Ed1P. All right, here we go. Ready? It says we set it to 1. We call this, and it's going to print out Run it. F you. It hates it when you do this like pasting code over the other code. Like it really hates that, man. That's crazy. It takes a while though, huh? Come on, babe, you can do this. You know what it's doing is all that syncing up. It's actually reading the header files, like the system header files from the container, and pulling copies over to the local machine so that it knows like it knows what all those things look like. Here we go, run it. Now we get a 2. Let's do this. Let's debug it. All right, so we just did the call, right? So here's 1, that variable, it lives at 492C. And what do we just pass in? 492C. That's the address of that variable called 1. It's an integer. And now we're just about to change it. Let's go look at it in memory. It's got a 1 in it, right? Sitting at, what was it? 492C. So that's 4920. 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C. So that's the address of that variable. And watch, it'll change. Big finish here. Oh, now it's a 2. Because we said the value at that address, is now a 2. And now it, sure enough, is a 2. It's cool, all right? Isn't that cool? No one's listening anymore. Yeah, let's keep going. See the difference though, and the difference in the signatures, especially. Here I'm saying, you know what, I'm going to call this function, I'm going to pass it the address. And then down here, I'm saying, you know what, there's an address coming in, I'm going to treat it as an integer pointer. That's all that says. I'm going to pass the address, so I use the address of operator. And once I have the address, I'm going to treat that address as an integer pointer. You could actually write this way too. That works also. That might be clearer. You guys kill me.
Is there a difference between having the pointer placed before the 1 or after the end?
Nah, no difference at all. And you know, honestly, I go back and forth. Like I think from a clarity standpoint, like just reading the code, that really says, hey, this thing I'm passing in is going to be an int pointer. If I do it this way, I guess I'm still going to read it the same way, just because I've read C for so long. It's like, I still see it as an int pointer. But for you guys, if you want to do it this way, that's probably like reading the code, it makes a little more sense. So I'm passing an address, and that address is going to be used as an int pointer. Can I do this? Yes. Well, no, the signature is wrong, right? I think that'll compile and run just fine. I still get a 2 in it. I think that's just accidental though, because now I'm saying, hey, treat that value as a long pointer and then set the value there as a 2. I mean, a 2 is going to be a 2, whether it's an int or a long, right? But that's how I would think about it. I'm going to call the function. I want to pass it an address of something. And in the function, when I receive that thing, I want to treat that as an integer pointer. And now I can do all sorts of stuff. I've got a pointer to something in memory. I can set the value. I can do calculations on it and so on. Just, what was this one? Cool. Cool. What else we got? I've only got a couple minutes left. Yeah, that's a slide about passing by value, passing by reference, and so on. Unless you're in a bar with a bunch of academics, don't worry about that. Let's just take a quick look at this, and that'll be it. So a new function for us. This one, set array, and let me just do a prototype for it real quick. Because I'm lazy, I'll do it that way. 2, 3, X. Bip, bip, bip. And that was set array. Cool. And where's our driver code? Here it is. So this is, it's going to look a little different, right? Because of just that little special case of the array. Oops. Paste. So that's our array from before. It's got 8 values and 8 integers. And now I'm going to call this, let me move it up so it's easy to read. Blip. Where's main? There's main. Sweet. So we're going to set up the array. And remember that in the case of an array, the variable holds the address of the first item. So I've got an address in numbers. Then I'm going to call set array. What I'm really doing here is, I mean, really it's that, right? It's the address of that array, but numbers already holds the address because it is an array and that's special to them. So I'm going to call set array with the address of numbers. Set array says, you know what, I'm going to treat that thing as an int pointer. It's an integer pointer. And now that I have so it's really just an address in memory, right? It's an integer pointer. Now I can do integer math on it. So I can say, hey, you know what? Go 2 ints up and set whatever value was there to 0. Let's put a breakpoint here. Still no questions. Awesome. I probably have to rebuild this, huh? Let's see if it picked it up. Oh, it did. Sweet. Here's our array. 1, 2, 3, 4, 5, 6, 7, 8 sitting there in memory. Now, this thing that I passed in has the address 24D0. So 24D0 is down here, right? So I know that's the first address it's the address of the first item, which is a 1. Now I'm going to go up to 1, 2. So this thing, I'm going to set that value. The value at that location is going to be set to 0. We should see it happen in real time. Oh, it changed to 0. It's a miracle. And then just return. And again, I'm not returning anything. I don't have to because I worked on that variable directly in memory because I had its address. I think this is so fun. I wish we could just stop the whole course here and not go into all the nitty-gritty detail stuff because this is so fun. I guess that's not how it goes. All right. Cool. I've got like 30 seconds left. So seriously, a pointer is just a variable. What value does a pointer variable hold? It holds an address. What's at that address? Bits, like some stuff in the memory, right? Once you've got an address, C is kind of out of the logic is out of the picture. It's like, oh, here's the address. Like, do whatever you want. It's like a big party in memory tonight. Like, I don't care what you do. But like, because we have the actual address of something in memory, we can manipulate those values all day long and do whatever we want to them within bounds. There's some bounds that we'll learn about later on in the course that the operating system puts around us. So we really can only access our memory technically. We should have named the course pointers, as I said, because from here on out, it's all pointers all the way down. And by the way, the last, don't forget the add drop deadline to not have a W is like in a week or 2. Just saying. You guys will be fine. You'll be fine. All right, any more questions? It's 3:15, time to go. Don't forget, no lecture on Tuesday because we're on Monday's schedule. I'll see you all on Thursday. And if you need any help with PS1, which has been posted, hit up your TFs, your CAs, post a question on Piazza. There's still tons of office hours left this week, today and tomorrow. That's it. Go, be prosperous, live long.
Thank you.
Thank you.
Bye-bye. Bye-bye.
Thank you.
Been fun.